Hello everyone, let's discuss this problem score sum. And before starting this video, I would like you to hit that like and subscribe button. And if you have any suggestions, feel free to comment down this video. So let's start. First, let's read the problem statement. You are given an array B of length m, and suppose fb is equal to this quantity, and we are given an array A of length n, and we need to find the sum of fs over all non-empty subsequences of A, and we need to print it modulo this number. And okay, and what is the subsequence? Subsequence is something we cannot change the order of the elements, but we can delete from it. So basically all the subarrays, but with the option of deletion. Let's understand this by the sample inputs. So first let's see, we have two numbers 1 and 3. So the possible subsequences are, since this is a 2, so there will be 4 subsequences. 1 will be 5, no element. Then we will have a 1, then 3, then 1 and 3. Okay, so for 5 obviously the answer is 0. For 1 the answer is 0 because we need at least 2 elements. Then for 3 the answer is still 0, and then for 1 and 3 it is equals to 1 minus 3 to the power 7, which is equals to 2 to the power 7, which is equals to 128. So that is the answer here. Let's see for 1 to 1. So we have n equals to 3 and numbers are 1 to 1. So since this is 3, there will be 8 subsequences. So let me write that down. 1 to 1, this will contribute 0, this will contribute 0, this will contribute 0. Then we will have 1 2, then 2 1, then 1 2 1. So 1 2 will give me 1 to the power 7. This will also give me 1 to the power 7, and this will give me 1 minus 2 to the power 7 minus 2 minus 1 to the power 7. Why minus sign? Because in this summation we also have minus 1 to the power I plus 1, right? So f of b is equals to summation 1 to m minus 1 ai minus ai I plus 1 absolute value to the power 7. Okay. So now that we have this, this is equals to 0. So overall my answer equals to 2. And for the last test case, I think it is pretty clear, but 1 1 1 1 1. So there will be like 5 2 to the power 5 possibilities, so which is equals to 32. I am not writing that down, but I think you understand that it will be 0. If you wrote it like this, all the possible subsequences, they will I mean all of them will be 0, and so the answer is 0. Okay, now let's see the approach. So the good part is there are no prerequisites, and this is purely a mathematics based question. And if you had actually tried brute forcing it for some higher n, you might have even guessed the solution. So the answer is very trivial, so that is the good part. And let's say my array is a0, a1, a2 and so on. For convenience purposes, I will just denote it by 1 2 3 0 1 2 and 3 and so on. Okay, now let's say if my array was only 0, there is only one possible subsequence, so 0, right? And if my array was a0 a1, so there are like 4 possible subsequences, 3 possible subsequences: 0 0 1 1, right? So now we can see that okay, let's do one more. So if we had 0 1 and 2, my subsequence will be like 0. Okay, then one of the possible subsequence will be 0 1 and 1, and other subsequence will be like 0 1 2 0 2, then 2. Am I missing something? 1 2, right? So these are the 1 2 3 4 5 6, 7 subsequences that will be possible for 0 1 2 case. And like if you see like what is this contributing, like if this is not contributing anything, and these three are contributing like mod of 0 minus 1 to the power 7 with a plus sign, then yeah, it is only contributing this. This is contributing me. So basically what I'm noting here is I'm noting the subsequences ending at I. I mean, obviously in 0 1 2 all these will be included, but these are the new subsequences. Like how should I put it? I think like if there are 0 1 2, so these are the this is the subsequence ending at 0, this is the subsequence ending at 1, and this is the subsequence ending at 2, right? So this is contributing like nothing, and this is contributing 0 minus 1 to the power 7. And what is this contributing? This is contributing 0 minus 1 to the power 7, then a minus of 1 minus 2 to the power 7, and then this is contributing 0 minus 2 to the power 7, and this is contributing nothing, and plus 1 minus 2 to the power 7. And if you see, these two get cancelled out, and and this contributes only 0 minus 1 to the power 7 and 0 minus 2 to the power 7, right? And what the interesting part is, like if we had a 3 here, then what are the new subsequences that we will have? First is 0 1 2 and 3. Like, let me just separate these. So if we had a 0 1 2 3, then let's note down some 0 1 3, 0 2 3, then 0 3, 1 3, then 2 3, right? And if I write this like a mod of 0 minus 1 to the power 7 minus mod of 1 minus 2 to the power 7 plus mod of 2 minus 3 to the power 7, this is contributing 0 minus 1 to the power 7 minus 1 minus 3 to the power 7, and this is contributing 0 minus 2 to the power 7 minus 2 minus 3 to the power 7. This is contributing 0 minus 3 to the power 7, 1 minus 3 to the power 7, and 2 minus 3 to the power 7. I think I missed one subsequence here. 1 2 3 is also a possible one. So this will contribute 1 minus 2 to the power 7 minus 2 minus 3 to the power 7, right? So 1 minus 2 and 1 minus 2 will get cancelled, and 2 minus 3 plus 2 minus 3 minus 2 minus 3, then 2 minus 3, and these are getting cancelled. 1 minus 3 will get cancelled with this, and all that is left here, like if I just zoom out a bit, you can see all this contributes is actually this much. So we have 1 2 2 times mod of 0 minus 1 to the power 7 plus mod of 0 minus 2 to the power 7 plus a mod of 0 minus 3 to the power 7, right? and this goes on. Like if you, like I can say that okay, if my elements are a0, a1, a2 and a3 and a4 and so on. Okay, so if I count the number of subsequence with even length and odd length here, then we see that okay, for a0 it will be none, but for a0 only. So if we try to count the number of subsequence with even length ending at a0, so it is 0, and for odd length it is 1. For a1 it is also 1 1. For a2 it is like 2 2. Like we can even see it. For a2 the number of where is it? For a2 the number of subsequences with even length is 1 and 2, and odd length is equal, right? Similarly for a3 it will be 4 4, and a4 it will be 8 8 and so on. And since a0 has a 0 left here, so that is why this is not getting cancelled, and some terms are left. And if I actually try to add all these, like if I actually try to add everything for if my array is something like a0, a1, a2, a3, like what do you think, how many times a0 minus a1 occurs? Like if I ask you how many times a0 minus a1 will occur, in 0 1 and 2 we have okay, so 1 is here. Okay, let me change the color. So okay, 1 is here, then then 1 is contributed by this one, 1 2, and 2 is contributed by this one. So here I can say okay, 2 to the power 2, and that is 4 times, right? And plus 2 to the power 2 plus something into a0 minus a2 is contributed, then some number of times a0 minus a3 is contributed, right? So here I can see that okay, it is 2 to the power 1 into 2 to the power 0, right? And this is for this array. So for an array of 4 elements, my answer is this, right? And if I had 5 elements, like if I had a0, a1, a2, a3 and a4, then my answer will simply be mod of a0 minus a4, a1. This will occur how many times? It will occur 2 to the power like 3 times, right? Because we have a0 minus a1, then we had these 3, so this will contribute to the power 3 times in this minus 1, right? When you make a power set of these, and minus 1 because we are because 0 occurs only one time, and that will remove that possibility when only these 3 occurs in the number of times a4 occurs in that number of combinations, right? And in 2 to the power 2, what, a0 minus a2 to the power 7, and then 2 to the power 1, a0 minus a1 to the power 7, and then 2 to the power 0, we don't consider this, 0 minus 0 doesn't occur, and finally take the mod, and that will give you the solution, right? So let's try to code this quickly and submit it. Okay, now first thing I need to do is calculate the powers of 2, right? So for that I will just see what is the maximum number of what is the maximum possible n here. So n goes to 5 into 10 to the power 5, so I will say okay, constant capital N equals to 5e5 plus let's say 3. Okay, and to okay, now we have that. Then I will make an array for, or maybe I don't even need to do that, but for efficiently calculating the power, I will use the binary exponentiation. I don't think it is required here, but just to avoid any TLE. Then let's take the integer input and then the vector. Okay, so now we have the array with us. Now what we did is we need to calculate a0 minus a1 these values and then do this 2 to the power, right? So basically we need an answer variable, right? And then reverse for loop, and this will start from n minus 1. Okay, so first thing we need to calculate is ai minus a0. So let's say x is equals to ai minus a0, and let's also take the absolute value. Okay, and I need to raise this to a power, right? So int y is equals to, or I can say, okay, binpo this to the power 7, because this function will calculate the power this to the power 7 and take modulus. Let's change this number here to this. Okay, so now this is to the power 7 and mod all, and the mod has been taken, and then what we did was we need to multiply the power of 2. So so what we can do is let's create a variable, and like an answer is equals to answer times this power and take mod, and after that I will just do pw times 2 and take the modulus and see out answer and I think this should work. Let's see. Oh, I made a typo here. Let's say answer equals to answer plus this whole thing mod, and I think now this should work. Yeah, let's submit it and see. And that gave us a correct answer. So if you were able to understand it, kindly like this video, subscribe to my channel, and I will see you guys next time. And